So now that we've talked about structured concurrency in more detail, I'm going to walk through a case study that will give you some experience applying these techniques in the context of a WebMVC style application. So most of the structured concurrency stuff we've looked at to this point has really focused exclusively on running it in a single process as a standalone app. Now we're going to step back and look at this more in the context of what we're talking about in this class, which are things related to client-server applications. So in this particular case, as you'll see, we're going to have multi-threaded client that's going to do some really cool stuff. And on the back end, we're going to have different strategies for doing primality checking of large integers. And we're going to do a couple of different implementations. We'll probably right now focus on the one that's the structured concurrency one, because that's our focus. But if you look at the example here in the EX1 project in the WebMVC folder in my Live Lessons GitHub repository, you'll see sort of a Rosetta Stone of different approaches that use completable futures, that use parallel streams, and so on. So you can kind of mix and match and see which approach you prefer. So let's first start talking about the way this program is designed. So the idea here is we're going to use Spring WebMVC to send and receive HTTP GET requests either one at a time or in parallel from the client to the server. And even when we send it one at a time, we can have a whole slew of threads that are all sending them in parallel, even though each thread is sending things one at a time. So there'll be a couple different variants there. All of these calls are synchronous. Once again, we'll talk later about asynchronous stuff when we get to that part of the course, and we start talking about Spring WebFlux. So the client is going to be able to send these requests either individually, like, here's an integer, is it prime? Thank you, I got the result back. Here's another integer, is it prime? Get the result back. Or you'll send a nice big array of integers, and it'll check whether those integers are prime or not, and then send back a list of results. And this can be either sent sequentially or using Java parallel streams. So we have a couple different options for this. Likewise, the server can receive these requests individually. If the client sends it one at a time, the server gets it one at a time. Or if the client sends it in bulk, then it gets it as a list of integers. And once again, it can be processed with various strategies. We're going to focus primarily on the parallel strategies, but just for kicks, we're also going to show how to do it sequentially to show you how much slower it is to do things sequentially and what a win you get with using multi-core and parallel processing. And what you'll see also, I think this is really cool. For the parallel streams version, the difference between the sequential stream and the parallel stream is infinitesimally minuscule. You just put in a different factory method to make a parallel stream as opposed to make a sequential stream. For completable futures and the structured concurrency, there's much more work to be done to make it run in parallel. But with parallel streams, it's really simple. As before, as always, we have a controller. And so this PrimeChecker controller is going to do what a controller always does. It takes the GET requests that come in and converts them into the appropriate Java types and then forwards them to the service to do the work. The service, much like we saw before, is going to take the request and then it's going to magically forward it to the underlying strategy, parallel stream, completable future, structured concurrency, et cetera, et cetera, et cetera. So you'll see how those things all work. Also, very nice, very cool, much like the design we looked at for the bearer quotes microservice. Same pros and cons. It's clever, it's efficient, but it could be a little brittle. I should probably actually put a hash table in there just to show you the alternative way of doing things. As always, we organize our code in a very structured way. The server side has a server folder that's got the controller and the application and the service plus the various strategies. That's almost identical to the bearer quotes case study, just now we're doing prime checking. It's got a bunch of common things, also very consistent architecturally in terms of how we organize this stuff. And the other thing that this shows, this is really cool, we show how to implement a connection pool. We'll talk about that, which is really fun. And we've got these utils that we use in order to be able to reuse basic functionality. And in this case, we're still sticking with Java 19 version of the code, so we're using futures and stuff like that. There's also resources that keep track of various application properties like the port name and the name of the microservice and so on. The client side is going to have a test driver that will measure the time taken to do the different kinds of strategies. It measures it from the client's perspective in an end-to-end way. So we'll see, we can basically do a bake-off to see which of these implementations runs faster, and we'll display the results. That's kind of fun. The client sends the HTTP request to the server using all these different Java frameworks, and we have some utils that generate random numbers and abstract away from the details of web programming. You can use those things in your code as well for your assignment. All right. Again, there's pros and cons. So again, very much like the Barra server example, make sure you remember this. May or probably won't appear on the next quiz, but it's good to know. All the service implementations run in a single process. So certain things are simplified. There's only one place to look. So configuring, deploying is very simple. Testing, very simple. You'll see how we use the Spring Boot test framework to automatically and automagically launch the server application from the test framework, from the test driver, in order to check whether things work. That's really nice. When you start going to things that use multiple microservices, not quite so easy to just get it to start up in one fell swoop. And from a security point of view, that also centralizes where you have to protect your code. We don't really use security here, but it would be easy to add in security if we wanted to authenticate the clients. Another plus is synchronous two-way requests and responses are pretty intuitive for developers. You've probably done that your entire time as being a programmer, unless you started programming with JavaScript and asynchrony, which you might have, but most likely you started out with Java or Python, which is more synchronous request-response calls, two-way calls. The cons, much like before, is there's only a single process, this guy here, and that means that we're only going to be able to scale this up as much as there are cores available. And if this process fails, then we're just out of luck. So that becomes a so-called single point of failure, single point of contention. What would the alternatives be if we were to program this with microservices and a more sophisticated orchestration engine for launching things or having things running as in a cluster of computers? We could scale this up much more. Production web services are built that way these days. We scale them up, scale them up, scale them out, and so on. This is just a simple example to show the point. And the other issue is these synchronous request-response calls may not scale very well. And that's because we've got a block waiting for the response to come back. That will become more clear when we talk about asynchronous programming with WebFlux. The particular issue here is that, let's say we're going to send over a list of integers to check for primality. The server side has to do all that processing, collect all the results back into a response list, which has to be buffered on the server, and then that has to be sent back to the client. And so the client can't start processing any of the results until everything's buffered up on the server and sent back. Whereas with asynchronous WebFlux approaches, the responses can be streamed back as they complete, so the client might be able to deal with things more rapidly. Okay, so that's just a quick overview of how things are designed to work here.